Hi everyone, welcome to today's session in pursuit of big data. My name is Demetrius, working for MIP Holdings, and today's session will be about our business case for using CDC to provide a big data solution. So what I'll do is I'll take you through our business case and then show you how to get started with CDC, and I'll tell you a little bit about MIP and our environments as well. It gives you an idea of the volume and the space we play in. Right, just go back. So that's it. I'll just take you through an introduction of MIP. Some of those the objectives we try to achieve, and then also a bit later the things we've learned just enabling CDC on our database. All right, our business case was MIP was primarily in the application development space, so we had a few applications that we delivered, and what we figured out was that there was a need for a reporting space, or we wanted to work towards AI and machine learning, and the foundation of that is data. So we looked at getting data feeds out of Progress databases into SQL databases in a near real-time manner, so that we could work towards that goal of getting towards AI and machine learning. It came out at actually the right time. So we started our journey in around about 2019, just before COVID. And as COVID hit, we were able to get our reporting in place so that we could, all the people that started working from home, we could start giving stats on how they were performing and those kind of things to businesses, you know. Right. A little bit about MIP. MIP is proudly South African. We are a Progress partner. We are approximately 500 strong with 400 software engineers. Our applications cover 22 million plus beneficiaries, and the company is run on the quadruple P principle, which is planet, people, profit, purpose. Also, we sponsor a non-profit organization called Tears, which focuses on gender-based violence in South Africa. So that's also one of the nice things. Some of the applications that we provide, and I'll tell you why it's relevant. Starting to use CDC has an impact on your database and your database administration. And so building a solution for one client is different to building a solution for 10 clients, which is different to building a solution for 100 clients, because it impacts the effort you need to put into administering those databases, right? So just to give you an idea, we've got 5 vertical applications, but they are built on top of one main application at the bottom, which is our research and innovation team. They provide an application called our digital stack, and that comes with one database and one code base. On top of that, we've got each of these 4 applications that are built, and each of those applications come with at least another database and its own code base. So what that means is every one of these environments has at least 2 databases, and in MIP we manage roughly 1,000 databases across our 74 clients. So that gives you an idea of when you start enabling CDC and you want to work with your databases, we had to think about what impact that DB admin would have on our environment. All right? It was an important consideration for us. So just a little bit about our different applications. We've got a healthcare risk and funding application. We've got an individual life and risk, a group life and risk, a lending system, and a funds, benefits, and annuity system. Right? So that's another thing. Because these are separate systems, our CDC implementation had to be dynamic, which meant we couldn't write static code to reference CDC tables directly. We needed to use dynamic queries so that you never tied in to one particular database. You know, you could run that code on any Progress database, which made it scalable for us. Okay. All right, MIP operate in 12 countries within Africa and 5 countries offshore. Those 5 countries offshore are a new addition to MIP because we've got our latest division, which is our International and Outsourced Development Division, which basically we have Progress skills which we lend out to other companies. Our available skills there is, you know, we cater for legacy open edge, character and GUI applications. We do modern web systems, pairs and web speed systems. We do maintenance and support, enhancements and modernization, and new system development there. And as I said, our newest division outsources to the UK, Hong Kong, Germany, Australia, Canada, and South Africa. Right. We've also invested heavily in our technology. We've got a development framework that we use internally. And as I mentioned before, our research and innovation department have a digital stack application, which is where we house our building blocks for the rest of our systems. It's stuff like, you know, workflow modules and those kind of things, you know, automation tools, basic foundations of systems. We also, as you know, it's difficult to get young people into Progress. It's tough in South Africa getting young blood. And so we started an internship, and we're investing heavily in people, where we identify and train on average of 50 software engineers a year. We take it in 3-month courses where we take in students out of university and train them in Progress. All right, and I mentioned before we are 400 software engineers within MIP. Okay, so maybe a bit about our use case. We needed to get data out of Progress and into a SQL database, and there was a particular reason for this. We are a software house, and we deliver applications, Progress applications. And if we have to spend money on developers writing reports, it's wasted effort for us. So what we try to do is separate our skill set and have our open edge developers focus on our OLTP systems and have them develop those systems. And if we can get the data out of our Progress databases into SQL, SQL has its own, SQL people have their own skills that are geared towards aggregating data and reporting on data. And so we've got a nice segregation of duties there. We've got a nice specialization of you know, using those tools. So our objective with our solution was basically to secure our production database. And what that means is, you know, the easy answer is always just enable SQL access to your database. So the problem with that for us internally was that it's so difficult to control the impact that those SQL queries have on your Progress database. If somebody runs a rogue query, it could halt your transactional system, and then you're stuck. So the whole idea of the solution is to lock down your production server so that your performance of your production machine is controlled only by the activity on that machine. There's no incoming connections to the server. What we will do on our production server is the production server can always talk out, but we never let anything connect into our production machines. And this is just an approach we took, and it's working well for us thus far. So one of the things that we wanted to do is we also wanted to get our data feeds near real time. And by that I mean we aimed for a target of getting data out of Progress into SQL within 5 minutes. What we're achieving now is an average of 2.5 minutes, 2 minutes, round about there. We also wanted to cater for multi-target and multi-source, and what this means is that we could have multiple progress databases feeding data into one SQL database, or we could have one progress database feeding data into multiple SQL databases. So that was a feature that we wanted. And again, one of the big things is minimal impact on production. We also wanted to make sure that there isn't huge amounts of downtime that's required to get these data feeds going. Usually when you need to get data out of progress into a SQL database, there's a huge extract procedure or possibly downtime, and it's a lengthy period of time to get the data out or to get a footprint out of progress and into SQL. So we wanted to cut down on that impact. And another thing as well, by removing the reporting workload off our progress database and onto SQL, it means that our production machines are doing less work. They're actually focusing more on our transactional systems, and our reporting comes off another server. Again, we support multiple ODS technologies. We send data through from Progress into Hadoop, Postgres, and SQL Server. We had started working on MySQL. We just never got any clients that pushed for that kind of functionality. Another one of the big things we were trying to achieve was we have a web application, and in our web application we wanted to have our menus reference our production screens, but we also wanted to embed reports that were sourced from another server which had a real-time sync from production, which would give a user a sort of a one system feel, and the user would never be or never understand that the production transactional system was being sourced from one machine where your reporting was being sourced from another. So I'll show you a picture of that a bit later. And again, our long-term goal is for AI and machine learning, and you need data to get started with those things. All right, so this is the architecture we chose, and CDC came out at the perfect time for us. Well, CDC was available earlier, but we got exposed to it at that point in time. And I think the reason for the session today is that when we started, it was a daunting task, like just understanding how CDC works from a high level before you get into the code helps you to get started a lot quicker. And I think that's what we want to do, is share some of those learnings so that when you start, you're not as lost as we were when we started. All right, so in this picture, the box on the left would typically represent your production machine, and the box on the right would typically present your ODS, or operational data store. And what we've done is on our production databases, progress databases, we enable CDC, and that starts tracking changes in the database. Almost like auditing, where it says that record had a change, and so it keeps track of that. And what we do is we dump that data out, we transfer that data out onto a separate machine, we ingest that data into a SQL database, and then we send an acknowledgement message back to production. Why is this important? So once you enable CDC on your database and you start tracking changes on a table, that database is going to grow, and it's going to grow fast. So if you leave it unchecked, you will very quickly run out of space, especially in our environment with our applications, which are really high volume. We hit our limits very quickly. So having this loop back where we get an acknowledgement message back on the production system had two benefits for us. Number one is it kept our progress database small, because as we sent the data out to the SQL Server database and we got a message back, we purged those change logs out of the progress database. The second benefit was that we only purged the data out of the CDC tables once we get the acknowledgement message back, which meant we can guarantee delivery of the data from progress to SQL. And if ever there was a break in transmission between the machines for whatever reason, for network maintenance or those kind of things, we have the ability to resend that data out from Progress to SQL. Right. We also built these steps in 6 individual pieces, so they operate by themselves, so that we could do network maintenance, and while the network is down, the rest of the steps continue to process. When the network comes up, everything carries, it continues to flow again. Right. I think one of the objectives I mentioned earlier was that we're always trying to lock down our production machine. And so it's important to note that when we are sending data from production through to our ODS, it is a push out, so production knows who it's sending the data to. And when we are getting our acknowledgement message back, it's a pull. So production is in full control of any traffic to and from it. So it's never initiated from the right side, it's always initiated from the left side. Good. Okay, so this was actually the objective. Again, that gives you an idea of what our system looks like. We've got a little menu structure on the left, and you can click on all of those menu structures, and it will open up operational screens which are sourced from our production server. And certain of our menu items, you could click on a menu item to run a report, and those SQL queries would be sourced from our ODS or our data lake, but it would give the user one experience, not 2 separate systems. We partnered with a company called Yellowfin, where we use that tool to visualize our data out of SQL databases. Okay. All right, I'm not going to go into too much detail here. It's just our different offerings we've got. We've got a real-time sync to our ODS. So what we do is, typically out there, we find that a lot of people struggle to get their hands on the data quick enough. So in our replication, we replicate the schema as is from Progress to SQL. So if the table has fields named a certain way on Progress, we do the exact same tables in SQL. And the reason for that is to get the data out as quickly as possible. The minute you start introducing transformations, you got lag. So our approach was that our real-time data feed would replicate the schema, and then we would have a separate feed from our ODS to our warehouse, which could be at longer intervals, 15 minutes, 30 minutes, 4 hours, depending on the client. And that is where we would do incremental transformations on the data. That's where we would start doing flattening of data and, sort of customizing the database more for reporting. And we could afford the lag between the warehouse and our ODS. Okay. All right, why CDC? So there are other solutions. If you want to report on your data using SQL, there are other ways of getting the data out, and some of our clients have used these ways, but there are pros and cons to these methods. So one possible solution is on your live database, enable SQL connectivity to your database, and any external systems can connect in and run SQL queries, and you've got your access. There's a downside. The downside is that your production system is vulnerable. Any row query will pull your system down. Okay, so to mitigate that, you could set up open edge replication, where you replicate from your master to your target, and that target could serve as your DR server, disaster recovery. And while it's doing that, you could enable SQL connections to that database as well. Downside is you can run SQL queries, but you don't get the full power of SQL indexing, of SQL aggregation, of those kind of things, because underlying, on the underlying side, it's still a Progress database there, and you're mixing 2 technologies there, so there's a translation layer. Another option is for SQL to pull data out of the replication target. And some of the clients have done that, where they've got a job running out of the replication target and they pull data out into SQL. There's a downside there as well, in that you have to do a full pull of data because you don't get notified of deletes of records. So if you've pulled data out into your SQL database and a record got deleted, there's no way of you knowing unless you do a full refresh of that table. All right. So CDC actually fit that gap really well for us. And I know there are other solutions out there. But for us, again, I think the thing to understand is that CDC is a capability on the database and it is there for you to use. And if you have no fear, go ahead and get started. So CDC is not meant to be persistent. A lot of our clients confuse CDC with auditing because the concept is basically the same. Every time a record changes, OpenEdge stores the fact that that record changes. So it doesn't have as much information about who did the change, but it's got a lot of information about the transaction blocks, the time of the change, and what other records were related to that change. Right, so again, we use CDC to replicate our OpenEdge database to SQL type databases, schema, and data. One of the newer use cases we are chasing is to do an OpenEdge to OpenEdge replication across operating systems. Now that gets a little bit harder. On SQL, it's really cool. You can send metadata about a table through to SQL, and you can create tables on the fly. In OpenEdge, that's a little bit more difficult. So that's still challenges we are busy working through. At the moment, what we do is we make sure that the source and target schemas are the same before we start our data feeds. All right. So again, another big thing here, another big reason for you to use CDC is if you've got your data in OpenEdge and you've got your application running on OpenEdge, you get your data fed out to SQL, and then your skill is focused on SQL. You've got two separate teams focusing on two pieces of delivery for your clients. Well, again, that's the way we chose to deliver it. Again, this is a bit basic for you guys to get started on CDC. Like I say, when we started, we sort of had to read through all the documentation to try and figure out how CDC worked. At the time, there was very little, but the documentation has grown immensely over time. To get started with CDC, the first thing you need to do is you need to have type 2 storage areas on the database. And you need to create I don't think you need to, but OpenEdge sort of advised that you create two separate areas for your CDC data and for your CDC indexes. Now, there's a reason for this. These CDC tables are really, really high activity. You can imagine in your application, every transaction block that gets committed stores the fact that a record has changed. So for every row ID in the database that has changed, you're going to store some CDC data saying this record has been created, this record has been changed, this record has been deleted. So it's really high activity. So there's a lot of writes and a lot of deletes as well. And the fact that the data is accumulating is one part of it, but the fact that we are reading that data out, sending it to SQL, and then coming back when we get an acknowledgement message and deleting that data is another high activity process on it. It means that on this specific database extent, you are getting high amount of writes and a high amount of deletes. I think I mentioned that the CDC data is meant to be transient. It's just not meant to be persistent. So the idea is to let it live in the database for as short a time as is possible. All right. So there's a pro-util command you can run. It's pro-util enable CDC, and it takes in two arguments, one for the data area and one for the index area. And once you do that, it creates some tables in the database, some underscore tables. These tables are frozen, so you can't really modify them. But at that point, when you've done this, the database is actually not doing anything extra. All you've done is you've told the OpenEdge database you can start tracking changes, but nothing is there yet. So these three tables get created in the database. We've got a table policy table, a field policy table, and a change tracking table. And for you to start tracking changes in the OpenEdge database, you have to create a policy. And that's when the changes start actually taking effect. Right. So the tables are initially empty, and when you create the CDC policies, we start tracking data. There are 4 policy levels, 0 through to 3, and policy level 2 has the least amount of data. All it does is it stores a row ID, and it says that particular record had this particular action done on it. And then the highest amount of data that gets stored is policy level 3, which stores the fact that a record had a change on it. In addition, it stores a copy of the table, schema-wise, with a before image and an after image of that data. So you can imagine in your big tables how much that space that consumes. In between, we've got policy level 1, where in addition to knowing that a particular record had a change on it, it also stores the fields that were changed, so the field name, so you can interrogate those fields. And then policy level 2 stores the fact that the record has changed, and it also stores the after image of the change. Right, so what the data looked like after the change. So, creating a CDC policy will always store a CDC change tracking table. For your policies 0 and 1, it will always, for every record you change, it'll create one record in the underscore CDC change tracking table. And then for policy levels 2 and 3, in addition to those tables, you will also get the replica of your table that you are tracking changes for. As an example, CDC underscore customer. That's the default naming standard, and we've stuck with it, but you can change the naming standard of your CDC tables. When you create a table policy, what OpenEdge does in the background is it dynamically creates a copy of that table with a couple of meta fields appended to the table. And the meta fields you got there are basically your transaction block number, a sequence number, partition IDs, stuff to tell you about when the change was made, how it was made, and along with what other data was the change made. I did mention that these tables are frozen, which means that there's limited actions that you can perform on them. Right. So you can basically just read the tables and you can delete them, that's it. Okay, working with the CDC tables, just check this. There are 2 ways for you to work with the CDC tables. The documentation is really good on Progress's website. You can either approach it from the Progress side or from the SQL side. As I mentioned earlier, we took the approach of sticking on the Progress side. We keep our technology segregated. So on our production servers, we keep only Progress, and on our secondary servers, we keep only SQL on them. So there's a lot of sample code, and literally you could copy the code out of the documentation and you could get functioning with that documentation. It's really, really nice. OpenEdge also have a lot of helper classes to help you focus on a particular change and for you to get the data out and to purge that data. We've got a lot of helper classes. Okay. Another big thing is when we started approaching our code, we were hoping to dump the data out of the CDC tables transaction block at a time. So we were looking at maybe getting out a group of changes that were made at a particular time and dumping that out. And we tried looking into it, but the indexes on the CDC table don't allow for that method of extraction. Not as far as I saw. So what we did find was the best way to get the data out of the CDC tables is table by table in chronological sequence. Change 1, change 2, change 3 that happened. Right. What it does mean for us is that if we are dumping table 1, and sending a batch of records through to our ODS, and then table 2, it means that you're potentially having data delivered to your SQL database while the related data is not yet there. But it hasn't been a problem for us so far because, as I mentioned, we are getting our data delivered at an average of 2.5 minutes through to SQL. So it hasn't bitten us yet. We do have plans for once the data reaches SQL to check for completeness of data before activating that data on SQL side. So that would probably solve our problem there. All right, so the operations allowed on the CDC tables, I mentioned this already. They are frozen, so you can only read and delete them. There is an exception. On this change tracking table, there is a user miscellaneous field that can be modified. It's the only one that can be modified. And what we do is we mark, every time we send a CDC record through to SQL, we mark it with a unique ID, so that when we get an acknowledgement message back, we send that unique ID back and we can compare to what's on the record and say, yes, this record was delivered to SQL, now you can purge that particular record. The downside of this is that that field is not indexed, not directly anyway. You've got to work through the other indexes, which is in chronological sequence. Okay, so some important considerations working with CDC. Locking, it's a big one. So what is nice about CDC is while your database is up and running, once you've enabled CDC on your database, you've got your extents, you can create a table policy on the fly, and immediately when a table policy is created, the database will start tracking changes in the CDC tables. You don't need downtime for that. You can create a policy and it will immediately start tracking changes, which is really cool. However, if your table is extremely busy, you're going to battle to find a lock on the schema for enough time for Progress to create the CDC tables for it. And so what we found is for most of our tables, we are able to create CDC policies, but on high volume tables where there's constant activity, we have to either switch off our application so we can quickly create the policy, which is literally seconds, or we just wait for a quiet time on our application. Our applications, however, do not have quiet time. We've got some of our tables run right through the night where we've got automated jobs constantly working on the tables. So for us, it does mean some sort of downtime. So that's on the sort of creating the policy side of things. We also found that the CDC data exposed some issues in our applications, which is really cool. We got a chance to deal with those. One of those things was, as we are traversing the CDC data, we get to check for locks on that data, because as part of your transaction block, when you are creating data and updating that data, while you create the record, Progress automatically creates the CDC table for that record. We get to see how many locks are in the database and how long we are locking the data for. So if we're finding that we can't dump the data out from the CDC tables because it's been locked, it gives us an idea that we've got to an issue on our application where we are dragging the locks for longer than is needed. Another interesting thing that we found as well was that if you've got procedural code with sort of one big transaction block, and in that transaction block your record goes through 5 changes, only one CDC record gets created. But in a microservice architecture where you've got potentially multiple services working on the same data, you've got separate transaction blocks, which means the volume in your CDC tables climb. So it's also an important consideration, and it sort of explains the activity on the database, moving from monolithic applications through to services, microservices. Another big thing is the CDC database area size. So earlier on I mentioned that there's a pro-util command that you can use to enable CDC on the database, and that keeps a separate storage area in your database just for the CDC data. So what we found, and again this bit is hard and we've learned from it, was at one point when we started, our processes stalled, and so the data started piling up on the CDC tables, which meant that database extent started growing because the data wasn't getting purged out of it. Eventually, when the line came back up and we started, data started flowing again, we were able to purge that data. However, the database extents do not shrink again. And the only way for you to shrink that database is to empty out the table, remove the policies, take away CDC, and re-enable CDC on the database. So it's almost like a watermark. The more you use, it's just going to keep that watermark there, and it's going to use that disk space even though those tables are empty. So you've got to keep your eye on those extents. Okay, data fixes and disk space. So as part of our deployments, typically when we deploy, we have data fixes that run across some of our tables. Important to note that some of our data fixes, if they run across all the data in the tables, it generates a huge amount of CDC data. So this is another one of the learnings that we found, is we started off using the highest policy level, which stored the most amount of data. It stored, for every change, it stored a parent record saying that there was a change, and it stored a before and after image of that record. But the volume of data is just incredible, and we are moving away from that, and we're not using that policy anymore. It's just too much overhead. Schema changes. Just give me a sec. Right, so applying database changes also need to be handled in a more controlled manner. If you, basically the data in the CDC table should be emptied out. You need to disable the CDC policies, apply your database changes, and then reactivate the policies. You don't have to do that. If you add a new field to an existing table that's being tracked by CDC, it won't impact the table. Table will continue to work. It just means that CDC capability on the database will not track that field. For you to start tracking that field, you have to create a new CDC policy and tell the new policy, start tracking the new field. Right? You can also get smart about dumping the data out. That's something we learned as well. Our code to dump the data out and to load the data into SQL started off using the table and field names, and that worked. It was good until we renamed fields and renamed tables, and then our feeds broke. And so we changed it not to work off the actual table name and field name. We used the rec ID or row ID of the table or the field. That means that our feeds or our code to dump the data out works regardless of whether there's going to be a change to your table name or field name. Right? Okay. Another important thing. So I mentioned the CDC database extents and how they can grow. Restores. If you're going to restore from your production environment into downstream environments like your dev or your test or your QAD environments, that CDC data is going to continue to grow as people make changes in those environments. So it's important to have a strategy in place so that once you restore from production to a downstream environment, you disable those CDC policies to prevent the growth there. Right. Well, that depends on your use case, because you could have it there or your data feeds could be in your downstream environments as well. Also, non-unique data dumps and loads, it becomes a problem because if you're dumping your data based on row IDs and you do a dump and load, those row IDs get regenerated. So the data will not survive a dump and load. Another important thing is that sequence is important because row IDs can be reused. So if you create a record, modify it, delete it, and then create another record, the new record could use a row ID of a record that was deleted, which means that when you're dumping data, you have to work in the chronological sequence that the data was captured in. Otherwise, you're going to confuse those two records. High activity tables, also to be aware of, and then TDE is another big one. So TDE basically just encrypts, it's transparent data encryption. It just encrypts your data at rest. But that's fine, you can run TDE on your database and encrypt the data. But when you create a new CDC policy, Progress is creating that table on the fly, and that data is not going to be encrypted. So every time you create a new CDC policy, you've got to rerun your encryption routines. Right. And I've already spoken about auditing versus CDC. Okay, so some cool or unexpected things we found, while delivering our solution is CDC gave us some insights into how our data was changing. We were not supposed to be changing primary keys on our database, but CDC revealed that to us. So while it becomes, it's a lot of volume of data to work with, in doing so you find problems in your application development, which is really cool. We also saw the number of changes that go through our application because, looking at your database, you've got maybe 100,000 records, and that gives you an idea of volume. But you don't really have an indication of how many changes a particular record goes through in its lifetime, and CDC starts exposing that. And one of the things we found as well is in certain cases in our application, we were updating our records unnecessarily, and CDC exposed that. It helped us to deal with that, those issues we were blind to previously. But in seeing the volume of CDC data, we were able to address that. Right. I spoke about transaction blocks as well. Monolithic code versus microservices. And then some other use cases we've got. We've got our big data solution, which is what we use CDC for. But there's other sort of use cases we are chasing. One is our cross-operating system replication. Progress to progress, different operating systems. That's a big one for us. And then zero downtime deployments, which is also another big use case that we'll be chasing. Right. Questions? Yes?
Any insights on the performance impact of enabling CDC?
That's a good question. Yeah. So, sorry, the question was any insights on the performance impact on enabling CDC? Yes, there is an impact because your database is doing more work. For every record that is being touched, your CDC tables are being used as well. In addition to that, the fact that I'm dumping the data out has another performance impact, and the fact that I'm deleting the data once I get an acknowledgement is another performance impact. However, that impact is so little that the performance gain we get from not doing the reporting on our production database it's just overshadowed. So that much. Any other questions? Yes.
CDC track records, for example, if you have a big transaction. If you have a big transaction of deletion, for example, you want to delete 1 year of order, in one transaction, you will have potentially a performance issue, an issue on lock table. Will have a lock table overflow.
Okay, yeah, it's a good question as well. Question is lock table overflows and how they impact CDC data. Just, yeah. In our experience, we found that Progress was really cool in dealing with that. They have catered for the internal limits of your lock table. So if you set your lock table to 50 records and your transaction is updating 50 records, the fact that Progress internally are creating 3 additional records, they've catered for that internally. Otherwise, it would mean that for every policy that you create, you would have to go and play with your lock table settings, and they've taken care of that. So it's not a worry. You deal with your -L parameter separately as you would normally. Okay.
I think you could increase it a lot on deletion, because deletion does not take a lock on the table.
Sorry, I missed that.
But if you delete 1,000 records on one transaction, without CDC, you will have only 1 lock.
Yes.
With CDC, you will have something like 2,000 lock.
Yes.
So you have to take care of
Yes,
this.
yes. Yeah. But again, so you again, I think the engine takes care of that. You don't have to worry about the setting, but.
I think he asks if you need to increase your -L now because you're running CDC.
No.
I think your answer is
No, you don't have to.
Yeah.
Yeah, that was our experience.
Yeah.
Okay. Right.
There is a limitation with locked data type.
That's a good point. It's one of our exclusions at the moment. So we don't have, we actually don't cater for lobs at the moment, but what we are doing is we're going to start storing, we're not going to use the highest policy level, which is policy level 3, we're just going to use policy level 0, which tells us this record changed, and our code internally, we're going to say, this record has changed, we will copy the lob out to a file, transfer that lob across to SQL, and then load it in. So currently we don't cater for lobs. Okay.
Any other questions? Otherwise, we can break for lunch and then afterwards a general session.
Okay. Thank you. Thanks.